Let's just go here. All right, I'm going to go on OneNote and see if that works any better. All right, we're going to start with the very hardest problem in chapter 14, and that is 14.72. All right, and so that is nitrogen gas reacts with 3 hydrogen gas to produce 2 NH3 gas. And that at 450 degrees Celsius, again here, they could be asking you to convert it to Kp, and they would need the temperature. But again, they give the temperature because your Kc is going to depend on the temperature. And this is a 0.159. All right, so you can see that your Kc is small, but it's not very small. And so this one can be done by successive approximations. However, it will take you 20 approximations. So at some point, I think doing the quadratic equation might be the better way to go. But it is less than 1. That is the definition of small. And so it can be done by successive approximations. All right, so the nitrogen's initial concentration was 1 mole in 2 liters. So this was 1 mole in 2 liters, both of those to 3 sig figs, so 0.500 molar. Your hydrogen is 3 moles in 2 liters, 3 moles in 2 liters. All right, again, both of those are 3 sig figs, so that is a 1.50 molar. And your NH3, nothing was said about the NH3. That means nothing was put in. All right, so you have a 0, it's going to go to the right. And so at the change then, minus the coefficient of 1x, minus the coefficient of 3x, plus the coefficient of 2x. And we know that x is going to be small. Again, small based on the k being small, which is based on 1, which it's not very small, but it is small, which means it is less than 1. So at equilibrium, we have 0.5 minus x, 1.50 minus 3x, and 2x. And so when we write our expression for Kc, concentration NH3 squared, everything's a gas, everything goes in, concentration of nitrogen, concentration of hydrogen raised to the 3rd power. All right, so now we plug in our equilibrium concentrations, NH3, 2x, it is squared, N2, 0.5 minus x. All right, and H2, 1.5 minus 3x, quantity to the 3rd, and that is equal to 0.159. All right, so here you can say, all right, so x is going to be small, and so you would say that you can neglect it, the minus x, you neglect the minus 3x. Again, you can do that, and I have done that, and it is a pain. So you can get x1, x2, x3. It will take you to x20, if not more, but I think I remember 20 successive approximations until you get the same answer twice. And this one is difficult. You have to multiply it by 3, 1.5 minus 3 times your number. You got to cube it, then 0.5 minus the number, multiply that, and then multiply it by the point. It's most of the time, successive approximations is the way to go. Not this one for me. All right, so here is where you're going to have to put your math skills to the work. There will not be a problem this hard on the test, but this is a good thinking problem. All right, so I have my 2x squared. All right, and I have my 0.500 minus x. And then I see that I have a common factor here. All right, so what I can do is I can pull out a 3. All right, so I can pull the 3 out. And I only want to do this because when I take this 3 out, this, when you divide by 3, is 0.5. And this, when you divide by 3, is minus x. And that's what this is. All right, so some people might see that and they would pull a 3 out and then they would get the wrong answer. You are not pulling a 3 out, you are pulling a 3 to the third out. And so we're going to take a 3 to the third out, and what remains is our 0.5 minus x to the third. All right, so when you pull a 3 to the third out, you end up with 0.5 minus x to the third. And that is equal to your 0.159. All right, so that is a difficult mathematic step. Most people do not see that step. All right, but still, you have to then solve the problem. You're not done yet. So on top, you got your 2x squared. And now you're going to combine your like terms. You're going to have your 0.5 minus x to the fourth. And so what I'm going to do to get rid of this 3 to the third, which is not 9, which some people will put, 3 times 3 times 3 is 27. And so I'm going to multiply both sides by 27 to get rid of that 3 to the third. All right. And so I'm going to take my 0.159 and multiply it by 27. Which is 3 to the third. All right, and so that gives me 4.293. All right, so now the reason why that was important is you see that you have a perfect square on both sides. So a number, any number can be square rooted. Now when you have your x values, you have to have a perfect square. And so that is a perfect square, that is a perfect square, and then you square root the number. So square root the number, get 2.07. All right, so this is 2.07. And this is 2x divided by 0.5 minus x squared. All right, now though, you can't say that x is a small number because now it's equal to 2.07, a number that is greater than 1. All right, I have not, so you do not do this by successive approximations at this point. Maybe it would still take 20 and you would get your answer, or maybe it doesn't work at all. I haven't tried it from this point. All right, so now you have to FOIL. So you're going to take your 0.5 minus x and FOIL it. All right, so 0.5 times 0.5 is 0.25. 0.5 times the negative x, negative 0.5x. And then negative x times 0.5, again, a negative 0.5x. And then negative x times negative x is positive x squared. All right, so that is the denominator. So let's put it in the denominator. So on top, we have 2x in the denominator. I will put it in the form of the x squared first, then minus the x, 0.5, negative 0.5 plus a negative 0.5 is a negative 1x plus 0.25, and that is equal to 2.07. So all I did was I FOILed the denominator and put it in the order that it should be in for x's, x squared, then x, and then your constant. All right. So now to get rid of that in the denominator, we have to multiply both sides by x squared minus x plus 0.25. So we have to multiply both sides by x squared minus x plus 0.25. All right, so then that is gone. So then you have your 2x, and now you got to multiply it out. 2.07 x squared minus 2.07 x plus 0.518. All right, and so now when you're doing your quadratic, you have to have it in the form of ax squared plus bx plus c is equal to 0. All right, so to get this side equal to 0, we have to subtract 2x. So you must subtract 2x from both sides. And so you will have 2.07 x squared minus 4.07 x plus 0.518 is equal to 0. All right, that's why I don't like the quadratic equation. It takes a long time to put it into the form ax squared plus bx plus c. All right, and so if it was just time, then that would be fine. However, there are many errors that can be made on the way to getting it into that form. All right, but in this case, there is very little choice, and so you have to, the equation will be given, negative b plus or minus square root b squared minus 4ac all over 2a. All right, so you have your a, it is right here, 2.07. You've got your b, it's right here, negative 4.07. You've got your c right here, 0.518. You will always get two answers. One will be a valid answer, the other will be an invalid answer. All right, so we plug it in. So a negative number, that gives you a positive number, 4.07. All right, so this time I'm going to do plus. Over here, I'm going to do 4.07 minus. These are my two answers. Plus the square root of b squared, 4.07 squared. You can put in the negative if you want. Doesn't matter. Negative times a negative is positive. All right, minus 4, and your a, 2.07. Your c, 0.518. And that is all divided by 2 times your a, 2.07. That's your one answer. All right, so it's plus or minus. This time we have to then subtract the 4.07 squared minus 4 times 2.07 and 0.518 all over 2 times 2.07. All right, so the first time it's the plus, the second time it's the minus, and that's why this is always a plus or minus. You're always going to get two answers for x. One is going to be a valid answer, and the other is going to be an invalid answer. All right, so let's plug in the numbers on our calculator and get our two answers. All right, so you should have then 4.07 plus 3.50, 4.07 minus 3.50, all divided by 4.14, all divided by 4.14. All right, so this answer for x is 1.83. And this answer for x .138. All right. So one of these is a valid answer and one of these is an invalid answer. So we go back up and look and see our question. And so the question is, what are the equilibrium concentrations? You can never have a negative concentration. And so when we write our x values, one being 1.83 and one being 0.138, all right, we see immediately that the 0.5 minus a 1.83 gives us a negative number. So the 1.83 is an invalid answer. And so our answer is the 0.138. And so you take your 0.5. So the question is, what are your equilibrium concentrations? All right, and so here we're going to put in our 0.138. Here we're going to put in our 0.138. And here we're going to put in our 0.138. And we will have our answers. So 0.362. So this is 0.362 molar. That is our equilibrium concentration of nitrogen. Uh, 1.09 is our answer for hydrogen. And 0.276 is our equilibrium concentration for NH3. And if you plug those numbers into your expression, you will get your 0.159. Are you going to get exactly 0.159? Probably not. We did a lot of rounding in the different places, but you're going to get something at 0.16. It might be 0.15876, whatever, 0.162. But anyway, it's going to be very close to 0.159 when you put those numbers in. All right, so here's a case where I say that the quadratic equation is the best. It is a rare case where I will say quadratic equation is the best. I try to not do the quadratic equation. All right, so that was the hardest problem in the homework. That was number 72. Let's do 1470. Hard, but not as hard. All right, so in 1470, we have PCl3 gas plus Cl2 gas in equilibrium with PCl5 gas. And the K value is 49. And that's at 230 degrees Celsius. All right, and we're going to put 0.4 moles in 4 liters. All right, and so we have 3 sig figs for the moles, 2 sig figs for the liters, so we just need it to 2 sig figs. 0.10, and that is for both the PCl3 and the Cl2. They are both 0.4 moles in a 4-liter reaction vessel. And that's all they say. And so if they don't say anything about PCl5, it is a 0. All right, and so here is where you have your initial, your change, and your equilibrium. All right, you can't have a 0. It has to go to the right. Minus x plus x. All your coefficients are 1. All right, so you have 0.10 minus x, 0.10 minus x, and you have x. Your expression for Kc, your PCl5, PCl3, and Cl2. All right, and so now we put in our numbers at equilibrium, and they are x, the amount for PCl5, 0.1 minus x for PCl3, 0.1 minus x for Cl2 equals 49. All right, so your K value of the cutoff is 1, so this is considered a large K value, which means X is relatively large, which means you cannot neglect X and do successive approximations. All right, and so here is another case where you will do your quadratic equation. So I'm going to do this by the quadratic equation, and then I'm going to do it by successive approximations. So let's do it by the quadratic. So you have to FOIL the denominator. So that is 0.01 minus 0.2x plus x squared. All right, so if you FOIL that out, you get minus 0.1x minus 0.1x. When you add those up, it's minus 0.2x. All right, so then I'm going to put it into the correct form, which is in the x squared minus 0.2x plus 0.01. All right, so I FOILed that out and I put it in the correct order, and that's equal to 49. All right, so just like we did last time, I'm going to multiply both sides by x squared minus 0.2x plus 0.01. Multiply both sides by x squared minus 0.2x plus 0.01. So that's gone, and so you have your x. And then we'll multiply our 49 through, is equal to 49x squared minus 9.8x plus 0.49. So when you multiply the 49 through, that is what you get. Again, it's got to be equal to 0. So in order for this to be 0, we have to subtract x from this side. We have to then, of course, do the same thing to both sides. And so you have your 49x squared minus 10.8x, negative 9.8 minus x, negative 10.8x, plus 0.49 is equal to 0. And now we have our A, we have our B, and we have our C. And so we plug it into the quadratic formula. Negative B plus or minus square root B squared minus 4AC all over 2A. All right, so now let's plug in our numbers. Negative B, B is already negative. Negative times a negative is positive, 10.8. Plus or minus, when you square a number, doesn't matter if it's plus or minus, 10.8 squared. Minus 4 times your A value, 49, times your C value, 0.49. All over 2 times A, 49. All right, so now we're back to pushing buttons. All right, so our two answers. All right, so we have 10.8, I'll do the plus one first, plus 4.54 divided by 98. And we have 10.8 minus 4.54 over 98. I'll do the plus one first. .157, we only need two sig figs, 0.16. All right, so that's one of your values for x. The other value minus. And that is a 0.064. All right, so one of these is a valid number and one is not a valid number. All right, so we have 0.16 and 0.064. So we go back up to our initial question, which is right here, 1470. We want to find our equilibrium concentrations. And so our choices are 0.16 molar for X or 0.064. All right, and so obviously when you have 0.1 minus X, X can never be greater than 0.1, and here is 0.16. That would give you a negative concentration. The 0.16 answer is an invalid answer. And so your X value is 0.064. And so your answers are the concentration of PCl3, 0.036, concentration of Cl2, 0.036, concentration of PCl5, 0.064. So those are your equilibrium concentrations. If you plug them into your equation, your expression, you put in your numbers for PCl5, PCl3, and Cl2, you will get 49. Or again, we did a lot of rounding. It might be 50, it might be 48, but anyway, it'll be very close to the number 49. All right, so I promised you that you would not have to do this one by the quadratic equation. So this is an important concept to know. Will you ever have to do it? Have to? No, you can always do the quadratic equation. This is the way that I will do it. This is the way I like to do it. All right, but again, it is very difficult. All right, so I'm going to take this. Still at the same temperature. All right, so I'm going to rewrite that, but I'm going to write it a little bit different. Okay, so the first part of this is something you do have to do for the test. So I have my reaction, but this time I'm going to write my reaction this way. PCl5 in equilibrium with PCl3 plus Cl2. My temperature is still 230 degrees. How do I find the K value for this? So what do? I reverse the reaction. All right, so, and then my initial, this was 0, this is 0.10, this is 0.10. So when you reverse a reaction, what do you do to your K value? You have to invert it. All right, so this is 1 over 49. I know that if my forward reaction is a large number, if I reverse the reaction, I invert that large number, and now I have a small number. All right, and so this is 0.020. So now I have a small number. All right, now if that was the end of it, then that would be great. All right, so that's not really the hard part. That's the part you have to know. I'm going to say, here's this K value. What's this K value? You have to know that when you reverse the reaction, your reactants became products, your products became reactants. You have to invert it. All right, but I'm going to call this, whenever I do this, and I have a 0 here, and I have a small number, I have to get a new initial. All right, and so this is the hard part. So I know that this is small, so I know that I'm going to have more reactants than product. So I'm going to subtract my new initial, and get my new initial. All right, so I know that it's going to go to the left until something is 0. So I have to get my new initial. My new initial is something is 0, not the reactant, something on the product side. All right, and so I know that the coefficients are both 1 and you get 1. And so for one of these to go to 0, actually they both go to 0 when it is a 0.1. All right, so they don't both have to go to 0. One of them has to go to 0. In this case, they are both the same concentration. They're both going to go to the left by 0.1 molar. And so you have both of them becoming 0. All right, and so this is my new initial. So here's the initial. I reverse the reaction. I have to get a new initial. And now I can do my initial change equilibrium. I know that these are not 0. I know they're small, but I know they're not 0. You have to form some. So here you're going to have minus x. Here you're going to have plus x. Here you're going to have plus x. And at equilibrium, you got 0.10 minus x. You have x, and you have x. All right? And so this is how, on the test, the problem is going to start. You're going to have this reaction. You're going to have this small k value. And you're going to know that x is small. And you're going to be starting with the 0.1. The new initial thing is going to be something that's going to be very helpful on the next test. But good to see it here that you reverse a reaction, you invert your k value. All right, and so now we have a small x, and so we can then say that a 0.10 minus x, this is your, this is how you do the concept of successive approximation, is you say that when you take your 0.1 and you subtract a small number, it's going to be still about 0.1. Now, you can't just say that and do it once and you're done. Successive approximations, you have to plug in those numbers until you get the same number twice. And so your Kc expression, PCl3 concentration, Cl2 concentration over PCl5 concentration. You put in your numbers, you got your x, you got your x, you got your 0.1 minus x, and you got your 0.020. All right, and so we're going to do successive approximations. So we're going to then neglect, anytime you have a plus x or a minus x, x is small, so it's not going to change that number. Those are the ones that you neglect. And so when you neglect that, to find our x1 value is very simple. So you have your x squared over the 0.10, not minus x, we neglected it, we say it's not going to matter, is equal to 0.020. So we take 0.1 times 0.02, and then you take the square root of that, and you then have an x1 value, the first approximated number, 2 sig figs, 0.045. All right, so that's as high as the number can be. Now we have to plug that in. So we neglected it right there. We have a number, and so now we have to plug it in. All right, and so now we have x squared over 0.10 minus 0.045 equals 0.020. You plug it in where it was previously neglected. So, and then we get another x value. All right, so x1 is as big as the number can be. x2 is as small as the number can be. This is to 2 sig figs, 0.033. All right, so the largest it can be is 0.045. The smallest it can be is 0.033. If it's a multiple choice, chances are you're done. It's a number between those two. Or maybe there's multiple numbers between those two. All right, so we got to do it again. So we plug that in. So we have a new x value. We plug it in, all right, to get our x3. And we're going to keep going until we get the same number twice. All right, and so we have our x squared over 0.10 minus 0.033 is equal to 0.020. And 0.037. So x3, 0.037. Then you plug that number in to get x4. So now you have x squared over 0.10 minus 0.037 is equal to 0.02. That will give us X4. .036. All right, and so it's going to take one more time because they are only differing by one. It's going to either be the 0.037 again or the 0.036 again. But regardless, this is the last time we're going to do it. So for x5, which will be our answer, x squared over 0.10 minus the 0.036 equals 0.020. .036 is the winner, x5. And that is your answer. So you got it twice. So 0.036, you got 0.036 again, and there is your answer. All right, so now we have to answer the question. And the question is the same as before. What are the equilibrium concentrations? All right, so now we know that our x value is 0.036. 0.036. 0.036. All right, and so we have our equilibrium concentration. So the PCl5 is going to be the 0.064 molar. The PCl3 is the 0.036 molar. The Cl2 is the 0.036 molar. And when you look at those numbers and you look at the previous numbers, you get exactly the same answer. All right, so it doesn't matter if you do it by the quadratic equation. You FOIL it, you get your ABC, you get your answers. All right, or if you reverse the reaction in order to get a small k value, now you have to get a new initial where you're going to shift things to the left until something on the right is 0. You got to go to the left, get your reactants until something on the right is 0. In this case, they were both 0. And then you reach your equilibrium. So again, there's more steps. So the concept of equilibrium, knowing that you reverse a reaction, you invert the K value, you have to shift things. The hard part of that is you got to shift things to the left until something on the right is 0. If you can do that, I think there could be less errors doing that than there are math errors doing the quadratic. But again, then you still have to do successive approximations. I love successive approximations. I know people don't like them. I will manipulate this reaction. I will do it by successive approximations. When you FOIL stuff and you're subtracting things, it's easy to make a simple mistake, and then you're like, what in the heck is going on? Then you got to start all over again. But successive approximations, my first number is the highest, my second number is the lowest, and they keep getting smaller until they meet in the middle, and then you have your answer. I like the way that works. I know if I pushed in a button wrong and something was higher the next time, then if it's the highest and the next one's higher, I know that something was wrong. So anyway, there will be a problem where you have to do successive approximations. I will not make a problem where you have to do quadratic, but you would, sometimes quadratic is easier. So you should know how to do both of them. All right, 68, 14.68. All right, so in this reaction, we have N2 plus O2. And that's giving us 2NO gas. K value here. .0123. All right, so I like to see that K value. It's small, and so I know my X is small, and so I can do successive approximations. All right, and so this one can be done. Now we're going to see that it can be done 3 ways. All right, and so we're starting with 0.850 moles, and dividing that by 8 liters. And in this problem, everything is given to 3 sig figs. So I take my 0.85, 0 divided by my 8.00.106. And so my initials for both the N2 and the O2. Right, so you have 0.85 moles each of N2 and O2 in an 8 liter flask. So there's your initial concentrations. Nothing said about the NO. It is 0, and so it has to go to the right, minus the coefficient of 1x minus the coefficient of 1x plus the coefficient of 2x. So at equilibrium, we have 0.106 minus x, 0.106 minus x, and we have 2x. Our expression for Kc, NO is squared, N2, and O2. All gases all go in their expression. All right, so we put in our numbers. We have our 2x, that is squared. Then we have our 0.106 minus x, and then we have our 0.106 minus x. So you can write it again. What I'm going to say is squared. So it's 0.106 minus x squared is 0.0123. All right, and so now we see that we have a perfect square on this side. So can this be done by the quadratic? Yes. Can this be done by successive approximations? Yes. Are those the easiest ways to do it? No. In this case, seeing that you have a perfect square is the easiest way to do this problem. All right, and so you can then take the square root of both sides. All right, and so you take your 0.0123 and the square root of that, and you get 0.111. All right, you take the square root of that, you end up with the 2x in the numerator, 0.106 minus x in the denominator. All right, so now you just have a simple Algebra 1 solve the problem question. All right, so you multiply both sides by 0.106 minus x. All right, and so you end up with 2x is equal to got to multiply that through. So 0.111 times 0.106 is 0.0118 minus 0.111x. So I distribute my 0.111. All right, so now I'm going to add 0.111x to both sides. I'm going to add 0.111x to both sides. So 2.111x is equal to 0.0118. To get x by itself, divide by 2.111, divide by 2.111, divide by 2.111, and you get your answer. So x is equal to 0.00557. All right, and so then you can get the answer to the question, which is what are your equilibrium concentrations? And so for your NO, it's 2 times that. So here you have your 0.0111. Right, and so I didn't see, I didn't clear my buttons. 0.00557. I'm using 0.556891. Okay, so plus 0.106. You got here to 3 decimals, 0.100 molar, and here 0.100 molar as well. All right, so your equilibrium concentrations, your NO 0.0111 molar, and your N2 and your O2 are both 0.1. And so you can plug those in to check your answer. So if we take our 0.0111 and we square it and divide that by 0.1 and 0.1, all right, I'm just plugging it into my expression here. Right, so we definitely rounded some of these numbers. So if I clear everything out and I put in the numbers for 3 sig figs, I'm going to be off by a little, no, or not. It's going to be exactly the same. All right, so when you do that, you get exactly 0.0123. So you can always check your answers. Many times it's not exactly the same to the last sig fig, but in this case, it was exactly the same to the last sig fig. All right, we will pick up there tomorrow. Your lab is not due until next week on Thursday.